This presentation is entitled Assessment of PV polycrystalline modules parameters dependence on relatively high solar radius and the project contribution à la modélisation, optimisation, diagnostic, contrôle avancé et gestion intelligente des performances des systèmes d'énergie renouvelable. All others are from GGL University, Electronic Department, Faculty of Sciences and Technology, except the second author, Abdelhamid Rabhi from Jules Verne University, Amiens, France. The purpose of this presentation is to present the developed methodology to assess and evaluate polycrystalline PV module, present results of MATLAB simulation, give analysis of results. Assessment of solar modules performance using real IV current voltage characteristics is strongly dependent on its operating environments. So to achieve a better understanding of the PV performance using double diode equivalent circuits, changes of variables V to V plus I multiply series resistance are imposed. The mathematical model of the double diode equivalent circuits is presented below. Developed methodology almost for three stages. The first is to calculate the equivalent series resistance from the slope of real IV curve at the vicinity of the maximum power point, as shown in the mathematical model at the point of 0.75 current at the maximum power point I and PP. Second, we calculate or we determine the shunt resistance, parallel resistance from the slope of IV curve at the short circuit region, as demonstrated with this mathematical model. The stage 3 is more important. It is our contribution. The remaining 5 parameters: photocurrent IPH, reverse saturation current IS1 and IS2, and ideality factors A1 and I2 are estimated by fitting the real I V plus I multiplier series attention data to the modified double diode mathematical model, where a change of variables is imposed. Some assumptions are done. The shunt resistance here is bigger than VPV, the voltage, and plus the APV, the photovoltaic currents, multiply series resistance. So, the saturation currents are equal for the two diodes. IS1 equal IS2, and both ideality factors are equal to I1 and I2 for the two line. For simplification of the presentation, we show the flowchart of all work. So first, we have the database of measured IV curves from real photovoltaic panels. The data are loaded to the MATLAB environments. So with those some MATLAB programs and model for the models are done, which allow us to calculate series resistance from slope of real IV curves at open circuit regions and shunt resistance from the short circuit region. And then we calculate the mean values or the base values of the both resistance, series resistance and shunt resistance, using the two mathematical models. We fit data, real data, to the mathematical model using trust region algorithm and mean squared techniques algorithm too. If the errors are accepted here using MATLAB environment, so the others or the remaining five parameters are done, which the photocurrents and saturation currents and identity factors from real IV curves. And then we calculate the base values of all those parameters to give simplified or the double-dyed mathematical model-based determining parameters. The slide presents the figure or the results of MATLAB simulations using real IV curves in the blue color and the fitted model with the red color. So this figure can demonstrate the effectiveness of the methodology developed and the methodology developed. In this work, the performance of evaluation of PV parameters is presented, fitting IP curve data to a power equation using no linear least squares method and trust region algorithm. It is observed that the simplification of double-dyed equivalent circuits estimate all 7 parameters could give better results in terms of accuracy to follow the physical behavior of PV modules. We consider this work as the first part of our objectives. So our fundamental objective is to make a lookup tables from all base values of 7 parameters for difference of several curves with different level of irradiation, and then we can do the same for shading effects, for recessive defaults, to go for a diagnostic and prognostic objectives. This is our goals in the next work as a perspective. Thank you again for coming, and we hope that this business is useful and interesting. Thank you.